Okay, everybody, I am redoing this video, and I am here by myself at school. Redoing this video because of the different way in which we do our calculations compared to the other way in which I had my original video. That's okay. We'll go through it fairly quickly. I'm going to tell you to pause the video to take the note so I can get through this as quickly as I can, and you can get through it as quickly as you can as well. Okay, so an acid-base titration is a very specific and accurate method that we use to determine the concentration of a solution that we don't know the concentration of. The idea of the technique is to take something that we know the concentration of and then react it with something that we don't know the concentration of, and then ultimately we can get the concentration through stoichiometry. So if I'm going too fast here, again, just pause the video so you can write it down, all right? So here we've got the apparatus that we're going to use, and I'm going to make a real live video in a moment to follow it up to show you how we do a titration, and that is so that we can continue with our lab tomorrow, all right, without me having to show it again. The three pieces of equipment that we use: a burette. It's a really tall, skinny, graduated cylinder. You can see it. I'll try to use the pointer in order to point it out. And I can't really see the pointer very well. There you can see my dot maybe. There it is there. That's called the burette. It's got a little tap on the bottom that we open and close. It's technically called the stopcock. I would click on my giggly button, but you can giggle if you want. But that's the technical term. It's the little tap that we open and close to let the liquid through. And then at the bottom here, we put an Erlenmeyer flask that we then collect the other liquid in order to do the neutralization. So the liquid that we put in the burette is typically called the titrant, and then we react it with whatever is in the Erlenmeyer flask in order to neutralize it. Again, you can pause in order to write the note. Easy way to draw these things, if you're wondering, just keep it simple. I would draw a burette with just a couple of parallel lines, a stopcock with a little circle and an X, and the tip just as a little triangle, and then Erlenmeyer flask. That is the worst Erlenmeyer flask I've ever drawn, but you get the idea, all right? So for your note, you can keep it simple as you draw and label, and I'll show you a real one in a second. So in an acid-base titration, we mix an acid with a base until it is completely neutralized. At that point, we have reached what is called the neutralization point, and that's where the moles of acid equals the moles of base, and we get this information from our stoichiometry. So we do it just like we do stoichiometry. We put in an indicator that changes color, and we've seen some indicators. We put an indicator that changes color at this neutralization point, and then that tells us when to stop. Again, you can pause to write the note. Okay, so now I'm just going to do a few examples of how we can do questions that you might see on a test, and then I will do a titration for you and show you exactly how we do the procedure so that we can do it tomorrow in the lab. So we've done a question like this before when we had our last unit. 17.5 milliliters of 0.247 molar barium hydroxide is required to neutralize 10 milliliters of nitric acid in a titration. I will tell you where all of these numbers come from when I show you my demonstration. All right? What is the concentration of the nitric acid? So again, we have a reaction, which means it is a neutralization reaction. And again, you can pause in order to write the question down, but I'm going to continue. And we've got some barium hydroxide, BaOH2, barium 2, hydroxide 1. It's reacting with nitric acid, HNO3. That is a hydrogen with a nitrate. And it is going to do the double displacement reaction to produce some barium nitrate, NO3 2, and then two waters will be formed. All right? we will need 2 of those. All right, so again, we need the coefficients to do the stoichiometry. As per normal, we write the information that we have underneath 17.05 milliliters. And that is being reacted with something of a concentration of 0.247 molarity or moles per liter. Again, we will use our C equals N over V in order to convert that into moles. The other information we have is 10 milliliters of the nitric acid. And in the end, we want to calculate that concentration. All right? What is the concentration of the nitric acid? And just like I said before, when we're looking for concentration, write C equals N over V. We can get the V from there. And once we figure out the moles in this position, we can put the moles in there. All right? And again, we've done a question like this. All right, so let me grab my calculator since none of you are here. It's actually no different than when you're in class. Okay, anyway. So we're looking for moles. So I'm looking for N equals, when I rearrange this, I'll get C times V, 0.247 molarity. And I'm going to keep that volume in milliliters, and I'm going to work in millimoles. These questions work out very nicely that way. 0.247 molar times 17.05 milliliters. And I will calculate that now. 0.247 times 17.05 equals 4.21 millimoles. So down here in this position, I have 4.21 millimoles. Just as we normally do, when we move over to the right, we will use the mole ratio. In this case, it is a 1-to-2 ratio. So I will double that, times 2, use whichever method you like to use, and that gives me 8.42 millimoles of the acid. I'm now ready to calculate the concentration. C equals N over V. The N is 8.42 millimoles. I've got 10.00 milliliters. And when I divide by 10, I will move that decimal 1 to the left, and that will leave me with 0.842 moles per liter, or molarity, of the concentration of acid. All right. So again, we take a solution where we know the concentration and we use it to find a solution that we don't know the concentration of. Okay. Let's do one more example, and then I will do a demonstration for you. All right. So again, here we've got, again, barium hydroxide reacting with nitric acid. But this time I'm expressing it, or I'm starting with a mass of nitric acid, and that's sometimes the way this can happen. So we can still do this. In this case, I want to find the concentration of the barium hydroxide. Again, I'm starting with 17.05 milliliters. All right? And here I'm starting with 10.0 grams of the nitric acid. You can see I've got the balanced chemical equation. It's the same as the last one. Again, you can pause to write everything down. And this time it's asking for the concentration, C equals N over V, of the barium hydroxide, which means I'm going to need the moles of barium hydroxide. I have the volume of barium hydroxide, and that will get it. Because I started with a mass of nitric acid, I'm going to use a molar mass and my molar mass equation to get my moles. And then again, I will use my mole ratio in order to get the moles of the base. HNO3 16 times 3, 14, and 1. 16 times 3 plus 14 plus 1, 63 grams per mole. Molar mass equals mass over moles. And if I want moles, I need mass over molar mass. The mass in this case is 10. The molar mass is 63. 10 divided by 63, 0.1587, so 159 moles of the nitric acid. 0.159 moles. I will divide it by 2 to bring it down to the 2-to-1 ratio. Divided by 2, 0.07936, so 94 moles, 0.0794 moles. And now I'm ready to get my concentration. I've got to be careful with this because in this case I have moles, not millimoles, which means I'm going to have to convert the milliliters to liters this time. So it's a little different. C equals N over V, 0.0794 moles over, now I'm going to divide that 17 by 1,000, 1, 2, 3, 0.01705 liters. So I move that decimal place 3 to the left. I still have my number, 0.0794 in my calculator. So I just have to press divided by 0.01705 equals, and I get a number of 4.65 moles per liter. All right? Okay. So there are two examples of how we can do a titration, do a reaction that involves neutralization to determine a concentration. The first example involved 2 solutions, and the second example involves starting with a mass. In tomorrow's experiment, we will start with a mass, so we will do a question like this number 2, or we will calculate it like this. And on Monday, we will do a reaction that involves 2 solutions, and so we will calculate it like number 1. Now at this point in the lesson, I normally do a demonstration of a particular reaction, and I'm going to now shut this video off, and I'm going to make an actual video of me doing a titration so that you can see it. You can copy this, this particular slide down. I'm going to be writing the information on the board because I can't do the smartboard recording at the same time as the real live recording. And the concentration of the sodium hydroxide I'm going to use is 0.50 moles per liter, molarity. And I am going to react that with an unknown solution of hydrochloric acid. All right, so you can pause and write this slide down. I'm going to stop, and then you can switch to the next video that is attached.